Good morning, good afternoon, and good evening, everyone, and welcome to this Inside Scientific webinar titled Assessing Toxicity and Health Risks of E-Cigarettes, How to Take Aim at a Moving Target. I'm Liam Samuel from the events team here at scientist.com, and I'll be your host for today. The webinar has been sponsored by DSI, a division of Harvard Bioscience, so a big thanks to them for helping to make this event possible. We're very fortunate to have Dr. Emma Karey with us today, who's a postdoctoral researcher fellow at the NYU Grossman School of Medicine and the recipient of 2 Society of Toxicology awards this year, the Women in Toxicology Specialty Interest Group Postdoctoral Fellow Achievement Award and the Regulatory and Safety Evaluation Section Award for Postdoctoral Excellence. Dr. Karey will present cardiovascular, respiratory, and toxicological research in both humans and mouse models that challenges the convention that endpoints used for tobacco research are sufficient to capture the health risks of vaping. And without any further ado, I'm very pleased to welcome Dr. Emma Karey. Emma, thanks so much for joining us today, and the floor is yours whenever you're ready.
Great, thank you, Liam. I also want to thank DSI and Harvard Bioscience for this opportunity to share some brand new clinical and preclinical tobacco data today. It's nice to see that there's some people interested in both of those on the talk. And before we jump into things, I just want to conduct another poll to get a sense of how this audience perceives vaping risks before we get started. So if you can answer this question of whether you consider vaping to be a suitable form of harm reduction compared to traditional cigarettes. Okay, so it seems like there's a nice mix, and hopefully by the end of this, it will stimulate some interesting discussions and subsequent science. So let's get started. So the outline for this talk and how it will flow. I'm first going to start with a smoky timeline. So I'm going to discuss a brief tobacco history and some key milestones. Next, I'll present some data that we've obtained from some tobacco cohort studies and talk about the potential risks of vaping to the primary e-cig user. I'm then going to switch gears and speak about tobacco product emissions more broadly as a significant source of indoor air pollution and the potential cardiovascular risks associated with that. Then I'm going to talk about perceptions of tobacco-related harm, which is what I just tried to poll you guys on, and how that might actually influence real harm. And then I'll end with some concluding remarks and take some questions. So let's get started. Okay, our smoky timeline begins with cigarette milestones. This infograph maps U.S. smoking rates over the past 75 years. Notice that since peaking in 1954, smoking rates have been steadily declining. Shortly after this peak marked the first time the Surgeon General publicly commented on smoking harms, citing the earliest causal evidence of smoking-induced lung cancer. Interestingly, this consensus would not be formally published for another 7 years. And I mention this because the feds have a history of kind of dragging their feet when it comes to commenting on and, more importantly, regulating tobacco products. Consider the FDA, whose attempts to regulate cigarettes were overruled by the Supreme Court as recently as 2000. Essentially, the Supreme Court agreed with tobacco companies, arguing that the FDA could regulate nicotine as a drug, but not cigarettes, which were merely a product that delivered the nicotine. And so it wasn't until 2009 that Congress finally enacted a law that explicitly gave the FDA jurisdiction over cigarettes. And this ushered in many of the tobacco policies we're familiar with today, including health warnings on packaging, several measures to discourage minors and youth from smoking, and this included a flavored ban as well on cigarettes. An additional measure to restrict tobacco use by minors came more recently in 2019, and this was with the passing of the Tobacco 21 law. And this raised the age of minimum purchase to 21. And they bring all of this up to point out that while scientists and medical professionals and even government agencies seem to be definitively aware and agree that cigarettes are a source of harm for more than 60 years, it's really only been in this past decade or so that they've been able to make policies aimed at protecting people from them. So now I want to recenter this timeline and bring e-cigs into focus. I'm going to start with a fun fact, which is that people have been floating the idea of e-cigs around for more than 50 years, which suggests, at least to me, that people have been thinking about how to design safer alternatives to cigarettes for about as long as we've known them to be harmful. And while Herbert Gilbert was perhaps the first to develop and patent an e-cigarette, this device would ultimately never be more than a figment of his imagination. In fact, it would take another 40 years before a man halfway around the world would ultimately create and market the e-cig we know today. So with that, I want to introduce Han Leek of China. And he has sort of an interesting backstory. After losing his father, a lifelong smoker, to lung cancer, he vowed to create a, quote, safer cigarette, and that was the impetus for the prototype that he developed in 2003. So the leak e-cigarette hits the US market in 2007, and I just want to point out that this was 2 years before the Family Smoking Prevention and Tobacco Control Act was passed. And despite there seemingly being an opportunity to include e-cigs in that original legislation, they were not included because they didn't qualify as a tobacco product as the law was written at that point. And so 9 years after coming to market, the FDA finally passes the deeming rule, which expanded the definition of tobacco products and allowed them to govern e-cigs for the first time. But in all fairness, it's not just the federal regulators that are playing catch up. The scientific community, myself included, struggles with this as well. This timeline maps vaping's 15-year history, highlighting the rapid e-cig evolution of devices on the bottom and important vaping data and trends above. The speed with which these devices change often means that any new data we generate are typically old or worse, outdated by the time they're published. And admittedly, it's hard to stay current when the target population continues to morph as well. While vaping may have started as a harm reduction tool for smokers, high school use of e-cigs has surpassed that of cigarettes by 2014. And consequently, most current studies have shifted their focus to understanding why these products are so appealing to tobacco-naive adolescents and whether vaping puts these kids at an elevated risk. So this graph shows tobacco use trends by product among high school seniors and was obtained from data collected by the National Youth Tobacco Survey. In contrast with the steady decline in cigarette smoking in dark blue, you can see an explosion in vaping in light blue that took place over just 8 years. Moreover, if you zoom in further, you'll see that this trend is not unique to 12th graders. It's true for middle schoolers, high schoolers of all ages, and college students. Notice how the change in slope of vaping trajectories changes shortly after the advent of Juul and Juul-like devices. But let's take a step back for a second and talk about what an e-cigarette actually is. At its core, e-cigs have 3 elements. They have a cartridge that contains the input e-liquid or vape juice that will be heated and then subsequently inhaled, the atomizer, which is the metal element that delivers the heat to the e-liquid, and the battery that provides the power to the atomizer when the e-cig is used. And so I want to just point out that regardless of what the e-cig you see looks like on the outside, every single e-cigarette has these components. And this is important to remember because e-cigs, like I mentioned, have evolved quite extensively over the past decade. And unlike most products which aim for some element of quality control to ensure a consistent user experience, e-cigs have kind of taken the exact opposite approach, where eventually all 3 of these components would be modifiable. And e-cigs are often referred to by their generation, which allows you to date them and gives you insights into their design. So the Generation 1 e-cigs were the first to come to market. This is the leak e-cigarette I mentioned. And as you can see, they look remarkably like a cigarette, and they were the least modifiable of all the e-cigs that have ever been made. A few years later, vape pens arrived, and this signaled the first of the Generation 2 devices. This was notable because it meant you could modify the input material, and more specifically, the flavor and the nicotine and the solvent and carrier ratio. In that same generation, though, a few years later, we saw some modular tank devices come out, and this allowed for additional variation in the voltage and power. And this allowed users to optimize their vaping settings and influence the flavor intensity, nicotine delivery, and vapor production. So Juul is a little different in that they were trying to develop a product that produced the same nicotine cravings as cigarettes, and they were able to achieve this by lowering the pH of e-liquids. And that protonated the nicotine, which made it more bioavailable. So when you use them, you got this really high intensity peak for nicotine in your blood, and then it dropped really quickly. And so that sort of simulated the same type of nicotine metabolism as a cigarette. And these nicotine salts also meant that it allowed you to dissolve more nicotine into solution. And some studies have measured as much as 59 mg per mil. And so as you can see, compared to sort of the Generation 2 strengths, which go up to about 36 mg per mil, this is significantly more than we had seen previously. And again, 59 mg per mil, just for reference, is equivalent to about the total amount of nicotine in a pack of cigarettes. And when the FDA cracked down on flavors, the law was designed to restrict cartridges specifically that were used by rechargeable devices. So essentially they were targeting flavors in Juul products. And the FDA ruling unfortunately left a loophole which allowed the sale of flavored e-cigs as long as they were either disposable or the liquids weren't sold in prepackaged cartridges. So, and additionally, another loophole that was there was that people realized very quickly the FDA only regulates tobacco products, and that synthesized nicotine in a lab would basically circumvent that oversight. And so that brings us to our final generation of e-cigs, which is our current generation, and these are often disposable flavored e-cigs that have varying amounts of synthetic nicotine. So It's important to remember that toxicity is a combination of a chemical's reactivity and the biological response. So if you look strictly at the chemistry literature, and I've just pulled a handful of articles dating back to 2014 for you to reference, you can see quickly that toxic chemicals have been detected in both e-liquids and vaping emissions. Moreover, several different potential sources of e-cig toxicity have been identified, including the flavors, the nicotine, heavy metals coming from the coils, potentially there's pyrolysis of sugar-based solvents, and when you adjust or increase that device wattage and power, you can also change the e-cig emissions and alter the toxicity. And so far, flavors have been the focus of most of the toxicity research and regulatory efforts, in large part because it's believed that flavors contribute to the appeal and use of e-cigs by adolescents. And sure, flavors can absolutely be a source of toxicity, but I think that these data suggest that it's clear that they're not the sole source of vaping-related toxicants. So when it comes to characterizing the adverse health effects associated with vaping, it's a little murkier. On one hand, you have medical professionals and academic research outlets, and they will often reference potential vaping toxicity, but typically they temper it in the form of a question, like maybe it is, we don't know yet. And on the other hand, you have public health outlets and tobacco industries who are pretty confident declaring that e-cigs are safe, or at least safer than cigarettes. And regardless of your point of view, it really feels impossible to avoid drawing a comparison between these two products. Conceptually, this makes a lot of sense. And while these devices do overlap in regard to their ability to deliver a respirable form of nicotine, they actually differ far more than they overlap, which makes it really hard to compare their potential toxicities. So several factors make it difficult to conduct an apples-to-apples comparison, in my opinion, either between e-cig studies alone or when assessing relative vaping and smoking risks, including a lack of these standardized parameters in all of our studies, assessment and identification of relevant endpoints, and the selection of your population. And this really comes down to, are we interested in understanding if e-cigs reduce harm in experienced smokers, or are e-cigs a source of harm in tobacco-naive adolescents? And that's why we need more data. And so with that, I'm going to present some data. Our lab has spent the past few years characterizing some novel harms associated with vaping. And so for the purposes of this talk, I'll be sharing some respiratory data that has been recently accepted for publication. We conducted a study that recruited exclusive vapers and smokers in New York City. And for reference, we also have non-smoking homes as sort of our negative control, and non-smokers will be in white and our vapers will be in blue. Oops, sorry about that. We quantified nasal inflammation, as this is a non-invasive and easily accessible endpoint that can provide insights into potential lower respiratory risks. And to help orient you, non-smokers, like I mentioned, will be in white and vapers will be in blue. And we're going to show aggregate means for each of the cytokines that we looked at. Statistically significant differences between non-smokers and vapers will be displayed in blue as well. And overall, 9 out of the 10 cytokines we assayed were elevated in the nose of e-cig users. So this was pretty striking. But like most people, we were curious how nasal inflammation that we found in vapers compared to that of exclusive smokers. And so it was really to our surprise that there was nothing really going on in the nose of our smokers compared to our vapers. And this is especially sort of shocking when you think about the fact that when we think about cigarettes generally, we tend to think that they're the most harmful tobacco product out there. And so we tend to think that that sort of represents one extreme end of that harm spectrum. So we also then looked at inflammation in the oral cavity, which is another non-invasive part of the upper respiratory system. And again, to our surprise, we really didn't find anything. Salivary cytokines from smokers and vapers were comparable. We also looked at salivary cotinine and found comparable cotinine levels in both our smokers and vapers, and that suggests that these populations are using these products to achieve a similar blood nicotine level. So I was pretty flummoxed by these divergent nasal responses, and a quick Google search suggested that perhaps I just hadn't done my homework, because there's actually a fair amount of evidence dating back decades that suggests tobacco-specific products and behaviors can lead to divergent health risks. So if you'll indulge me for a minute, I want to travel back in time, and you can see that 50 years ago, it was known that combustible tobacco consumers use their tobacco products differently. So tobacco smokers overwhelmingly report inhaling partly or deeply into their chest, more than 80%. In contrast, pipe and cigar smokers report that they don't inhale tobacco smoke at all. And this may not seem interesting on its own, but it's now been shown that smokers who report inhaling deeply into their lungs are at greater risk for lung cancer. Meanwhile, in cigar and pipe smokers who don't inhale, they aren't exactly evading tobacco-related cancers, but their lack of deep inhalation does appear to bias their cancer risk towards upper respiratory tissues. So together, these data suggest that how you use a product, even when the constituents are the same, in this case, combustible tobacco, can affect your health risks. So how does this relate to vaping? You're probably familiar with the large clouds generated by vapors, and it's a very distinct feature of these product users. And if you zoom in, you may notice that there's something a little different about how these people exhale. They don't just use their mouth, but some of them also exhale from their nose. And if you're having a hard time picturing this as a regular occurrence, you're not alone. I'm not sure I even noticed it until I started looking for it. But then I started to see it everywhere. And their tobacco community actually has already coined this term. They call it retrohaling. And what this means is that people actually intentionally force the product emissions through their nose when they exhale, and that's supposed to enhance the sort of flavor and sort of sensation of the experience. And so I thought, okay, if people are vaping that vape are retrohaling, and then they're intentionally exhaling from their nose, which would then in theory expose these nasal tissues to greater amounts of e-cig emissions, maybe this could explain the increased nasal inflammation that we see. And so as I'm learning more about this, I found myself in some very strange rabbit holes, all in the name of research, of course. And perhaps one of the strangest rabbit holes was some of the vaping Reddit threads that I found, where myriad accounts from vapors refer to retrohaling and why they do it, how to do it better, all of their recommendations. And I think jackpot. So I'm going to share a few choice quotes with you over the next couple slides, starting with this one. And this person says, "When I smoked cigs, I would never exhale from my nose. I looked like a dragon." And so I just want to point out that the community seems to be very aware of this behavior, and they're discussing it, and the implications of that we don't know yet, but it's sort of interesting. So vaping and retrohaling, is this a fad or a phenomenon? With these findings from my sort of Google searches and Reddit quotes in hand, I confidently approached my PIs and I told them, I think I figured it out. I think this is why we're seeing this novel nasal inflammation in our vapors. And without skipping a beat, my boss shoots me down, tells me no, he doesn't believe me. And I'll spare you the details of this particular verbal spar, but I ultimately wore him down and he says, okay, fine. You really think this is true? Go out and prove it. And so with that, my colleagues and I took to the streets of New York City to essentially creep on vapors and smokers and see if we could figure out if there were differences in how they use these products. So what we did is we looked at e-cig users and smokers, and we looked at whether they exhaled their emissions from their mouth alone, their mouth and nose together. And here you see in the center, there's a photo where they're doing it at the same time. We didn't typically see this. We usually saw them use their nose and then their mouth. And sometimes we looked at and then we tried to see if they use their nose exclusively. And what was really striking is we found about 120 vapors, and that 62% of them exhaled from their nose at some point. When compared to cigarette smokers, there was a dramatic difference in these percentages. So compared to cigarette smokers, if you consider e-cig exhalation from the nose, mouth alone, or mouth and nose together, you see a three times greater likelihood of nasal exhalation compared to our cigarette smokers. And when you look at just exclusive nasal exhalation, you see that that percentage goes up to 4 times as much. And so this was really interesting and surprising, sort of validating for me. We also then looked at the effect of the device type itself on this behavior. And we found some distinct differences as well, where mod users were much more likely to exhale from their nose than were pod users. And we don't really know why this is happening. I could guess that it has to do with maybe there's greater emission volumes with mod devices, and maybe they need the additional respiratory pathway to push those emissions out, or pods because they are more like a cigarette. Maybe people that use them try and emulate cigarette smokers more. We don't really know. It's just behavioral study, but sort of an interesting and striking finding. And so you don't have to sort of take my word for it. You can see for yourself. There's a really cool study that I'm going to reference now where they looked at nicotine deposition after a single puff. So Sai and colleagues recruited participants to inhale either an e-cigarette or a cigarette containing radio-labeled nicotine. And after 20 minutes, they did a PET scan, and they tried to figure out where nicotine deposition was taking place. And the pseudo color scale on the right is going to indicate the relative dose. So warmer colors and more red are going to indicate greater nicotine depositions. Cooler colors indicate less nicotine. So here's a representative image you can see from a person that vaped an e-cigarette one time. And you can see that they've labeled 6 areas here, and you can notice that there's a higher concentration of labeled nicotine at locations 1 and 2, which correspond to the mouth and the vocal cords. If you zoom in, I've added some additional labels, and you can clearly see a decent amount of nicotine deposition in the nose, labeled A. When you look at a cigarette smoker and the deposition there, you can see that there's a dramatically different profile. And importantly, I'd like to point out that the nose appears to have less nicotine deposition than the vapor on the left. They then subtracted the cigarette scan from the e-cigarette, and they showed that there's a higher retention of nicotine in the oropharyngeal, tracheobronchial, and stomach areas after vaping compared to smoking. And so this again sort of suggests that they're using these products differently internally, not just externally in how they breathe out, but this sort of also corroborates some of the findings we had. Yeah, and you can see that, the labeled areas where it's higher after they subtract. And so this got me thinking why retrohaling might be appealing to vapers but not smokers. And so when I think about taste, I always remember that, smell is really a way to enhance that. But I'm not a tobacco user, and I felt pretty out of my depth. So I figured, let me go to my favorite source, and that's not Google Scholar. It's going to be Reddit. And so here's again some sort of choice quotes for you. This person said, I exhale most of the smoke out of my nose. I just think it tastes better. Another person said, I exclusively exhale out of my nose. That's how I get the most flavor. Another person said, I probably exhale 50-50 out of my mouth and my nose. And so I couldn't help but notice that several people explicitly mentioned that taste and flavor are a reason that they prefer to retrohale. So I wanted to know exactly how many vapors were using flavored products and whether these comments reflected the majority of vapors or just a small subset. So work by Owens and his colleagues gave me some insights, and what they did is they took a large cohort of vapors and they just quantified how many of their e-cig users reported using a flavored e-cig. And so when they looked by age, and just the darker bar for reference is going to be the reference group they compared it against. And so you can see that by age, younger demographics certainly prefer to use flavored e-cigs more often. That sort of regardless of sex, there's a pretty equal distribution in terms of the majority using flavored products. It doesn't really matter where you are in the country. The preference seems to be similar. And when you look at cigarette smoking status, you can see that compared to current smokers, never and former smokers do seem to prefer flavored e-cigs as well. So in conclusion for all of this, I just think it's important to remember that these vapors seem to be aware of these flavors and how retrohaling can sort of enhance that. And this person said a deeper flavor profile is obtained when they do this, and the nose is better for tasting. So I've just talked about some novel respiratory harm we found in our vapors, and that flavored products may encourage a behavior that increases these risks. The good news is that 2 years ago, the FDA did enact their first ban for flavored e-cig products, although this ban, again, only applies to cartridges designed for rechargeable devices, but it is a start. And just last year, the FDA did enact stricter requirements for newer tobacco products, and this is done with a PMTA, which is a pre-market tobacco application. And basically what this requires is that any new tobacco product seeking FDA marketing has to provide details on the physical aspects of the product and information about the product's potential public health risks. So now I'm going to sort of switch gears and move away from primary health risks associated with vaping and discuss the impact of tobacco emissions on air quality. So we're going to go back to that tobacco milestone one more time. And I want to bring your attention to 2006. This was the second ever and most recent consensus that was put forth by the Surgeon General about the health harms associated with secondhand smoke or environmental tobacco smoke. Notice that this was just 1 year before vaping came to the US and almost 50 years after we knew smoking definitively caused cancer. And in the time since that 1964 report about that linked smoking and cancer, there's been an estimated 2.5 million non-smoking deaths attributed to exposure to secondhand smoke. And so the CDC suggests that about 75% of the morbidities associated with secondhand smoke are cardiovascular in nature. And it's estimated annually that about 33,000 people die from heart diseases related to that secondhand smoke today. And more importantly, there's no safe level of secondhand smoke exposure. There's no risk-free amount of exposure. And so here's just sort of a diagram showing some known pathways that are affected by secondhand smoke exposure. And for the purposes of the next several slides, I'm going to focus on autonomic dysfunction because that's what I studied when I was in grad school. But obviously there are others. And so I want to sort of introduce a seminal paper that was the impetus for much of the work that I did. And this was an Arden Pope study from 2001. And he had this clever idea to go to an airport because there was a definitive or a defined smoking section and a sort of non-smoking section. And this is the early 2000s, so again, it's different than it is today. And so essentially he hooked up some participants to an EKG, and he wanted to see what was going on with their autonomic regulation. So there was a non-smoking and a smoking section. He let them sit in these places for 2 hours at a time. On the left-hand side, you can see the mean number of lit cigarettes for each of the smoking windows. And on the bottom, the associated PM3 that was related to those, the number of cigarettes in each of those time frames. And on the right side, you can see there's their heart rate variability, which is one measure of autonomic dysfunction. And this is specifically overall heart rate variability, or your SDNN. I'll get into that in a second. And basically, he wanted to see what would happen to this heart rate variability when people were in a smoking section. And so he took these participants on the left, and you can see there's 9 individual participants that will be mapped. And when they went into their first smoking section, you can see that their heart rate variability did drop for the most part. Differing levels, obviously people have unique backgrounds, but this trend was consistent. They then, after 2 hours, went back to a non-smoking section, and there was a decent amount of recovery. And then they went back to that smoking section again, and you see again that downward shift. And so this was sort of striking because it suggested that secondhand smoke can impair vagal cardiac regulation acutely, but that this actually may be a transient effect. But we don't know what the long-term consequences of secondhand smoke were on autonomic regulation in sort of a mechanistic way. So that's what I was studying for my doctorate. And so to get at this, we did a rodent study. So we took these DSI telemetry implants, the HDX11, so we could get EKG recordings. We implanted them. And then we exposed our mice to either filtered air or 3 milligrams per cubic meter of secondhand smoke for 6 hours a day, 5 days a week, for up to 12 weeks. And then we did weekly recordings, so continuous recordings of EKGs, and we actually did 36 hours. So we did, the animals are on a 24-hour circadian cycle with a 12-hour light, 12-hour dark cycle. So we did 2 dark cycles and 1 light cycle, or in 36 hours. But for the purposes of this talk, I'm just going to focus on the first 24 hours of data, and then that 4-week and that 12-week time point, because we don't have infinite time. And so I just want to point out before I get into the data that in the Pope study, the heart rate variability was measured during secondhand exposure. And in our mouse study, we looked at heart rate variability post secondhand exposure. So slightly different paradigms. So why heart rate variability? Well, we know rodents are vagally dominant. We have data to show that. And it's a clinically validated risk factor. So we do know that it has some utility in the clinic. So here you can see a mouse EKG on the right. And you see this like really sharp QRS peak, and that's what we're going to use for our HRV analysis. And the only criterion for HRV is this normal to normal EKG waveform, which you can see sort of a representative sample to the left. And as Liam mentioned early on, I did give a webinar sort of on how to clean up rodent HRV data and EKGs because they're really messy. And if you're interested in that, there's a whole webinar you can access anytime. But I'm not going to spend much time on that anymore. And so when you're looking at heart rate variability, there's 3 sort of subsets you can look at. You can look at that overall variability, or that SDNN, and that's going to be your standard deviation of all the normal to normal RR intervals. So you can see just of all your R intervals together, what's the overall deviation. You can also break that up into shorter time segments, and that gives you an index of intermediate variability. And this is where you really start to isolate that autonomic contribution to variability. And then you can look at instantaneous changes in heart rate variability, and that's going to be your RMSSD, or your root mean squared of the successive difference, so that delta between each adjacent heartbeat. And that's going to give you really just that vagal input into that regulation. And so we know that changes, or specifically reductions in heart rate variability, are associated with increased arrhythmic risk. They increase your risk of sudden cardiac death, and they're associated with numerous diseases, including hypertension and depression and things like that. So we know that there are lots of pathologies associated with this. And in addition to doing these continuous recordings, we also did a stress test. And essentially, after those 36 hours, we took the mice and we gave them a 6-hour window where we did a 2-hour baseline. So here's your mice in that next day cycle. He's resting, he's chilling. After 2 hours, he's going to go into a restraint. And we literally just essentially put him in jail. We physically restrain them for 2 hours. And then when we release him, he's sort of relieved, but oftentimes they're a little discombobulated. And so we're looking at a 2-hour recovery window. And we wanted to see how stress would sort of potentiate any effects from secondhand smoke on cardiac susceptibility to arrhythmias. And we, like I said, so we're looking at these EKGs here, and specifically for the purposes of this talk, we were looking for PVCs, or preventricular contractions. And this is a contraction that is not simulated by a sinoatrial node impulse to the heart. This is really originating in the ventricles, and this is just one type of arrhythmia. We looked at several, but again, I'm going to focus on this. So for that 4-week time point, and again, just to help orient you, on the upper right, you're going to have your heart rate variability sort of guideline ready for you. And then you're going to have your measures of heart rate variability, and specifically just one example from each type on the graph to the left. And you're looking at the percent change from their equivalent baseline. And keep in mind, again, there was a dark and a light cycle. There can be some circadian effects on heart rate variability, so I'm going to separate them for you here. And when we looked at the dark cycle, you can see that when it comes to overall and intermediate variability, there was a modest decrease, but nothing really important going on at this point. When you look at that that short term, that vagal component, the RMSSD, you see a dramatic decrease in the dark cycle after 4 weeks of secondhand smoke. We looked at the same thing in the light cycle, and very similarly, we saw a dramatic decrease in the short-term variability, but not much going on with the sort of larger time frames of variability. And what about the restraint test and those arrhythmias? So again, we're looking at these PVCs. And at baseline, there's really nothing going on. You do see a stress-mediated increase in arrhythmias during the restraint window, which we totally expected. But when they are freed from that restraint, they go back down to recovery, nothing is different. So really, with 4 weeks of secondhand smoke, the only thing we saw that was changed significantly was that reduction in the short-term variability. So what happens if you continue this exposure for 12 weeks? So again, we did those recordings for 24 hours, and I'm going to show you that light and dark data together now because you're familiar with the layout. And again, the percent change from baseline filtered air. And by 12 weeks, what I hope you guys can appreciate is there's a dramatic decrease in all 3 measures of heart rate variability, that overall, that intermediate, and that short term. And in addition, if you're sort of curious how much more they were decreased from that 4-week time point, I've just put those percentages on the bottom there. So you can see there's a pretty dramatic decrease in overall and intermediate, likely less in that short term due to the fact that they had already been sort of attenuated so much that there's probably a physiological threshold they can't go beyond. So you see at 12 weeks of secondhand smoke that at baseline, there's not much going on with our between our secondhand smoke and filtered air mice. That restraint window does start to sort of separate. You see that there's a trend for a stress times exposure interaction between the secondhand smoke and that stress during that restraint regarding PVCs, but not statistically significant due to probably power, and that when they're allowed to recover, they return to baseline like nothing has happened. So these data kind of suggest that maybe if you are exposed to secondhand smoke and you are stressed, you are at greater risk for arrhythmias, but otherwise you sort of may never notice any effects. So to recap, I just showed you guys that with 12 weeks of secondhand smoke, we saw changes in autonomic dysfunction and all 3 measures of heart rate variability. We also saw that there was a trend for an increase in arrhythmic risk as evidenced by increased PVCs. But we've also had some other colleagues that have looked at the same cohort of mice for some other mechanisms of change from secondhand smoke. So some of our colleagues looked at electrophysiological studies and found reduced excitability of those cardiac vagal neurons. And those are the neurons that are relaying parasympathetic signals to the heart. So that's likely an upstream mechanism that could explain that reduction in heart rate variability that we saw. And 12 weeks of secondhand smoke also appears to disrupt several mechanisms that regulate myogenic tone, so potentially influencing endothelial dysfunction. And so this is why smoking bans are important and why we need legislation to restrict environmental tobacco smoke. Here's a map of the US that shows states with comprehensive laws restricting smoking in public places in green, and they become less comprehensive and less strong down the color scale. So states in gray have the weakest laws. And as you can see, there's still a lot of work to be done. And these laws are important because they protect non-smokers from new secondhand smoke-related harms. But I just showed you that some data that suggests that 12 weeks of secondhand smoke can sort of cause cardiovascular dysfunction via several mechanisms. So what about people who've already been exposed, say in these gray states, who currently have weak laws? Are these bans helpful to them? Well, we wanted to find out, so we actually simulated a smoking ban where after 12 weeks of exposure, we allowed our mice to, quote, recover. And so we tried to see if we could see improvements in their cardiac health as a result of this ban or recovery window. So did it work? So here again, you're going to see that same 12-week heart rate variability data that I just showed you. I've just adjusted the color scheme to make it easier to compare to the recovery data. And when we look at 4 weeks of recovery, you can see that, and again, the new data are going to be in the darker shades. You can see that there actually is a decent amount of recovery towards back, these heart rate variability parameters are moving back towards that baseline. And so this is really encouraging. It suggests that, yes, in fact, recovery can sort of reverse some of these effects. And if you look at, again, the percent increase now in all of these heart rate variability measures from that 12-week time frame, you can see that there's a pretty modest increase in all of them. But what about our arrhythmic risk that we saw? So again, here's your 12-week PVC data that I sort of lightened just so you can see the new data on top of it. And when we look at 4 weeks and that stress test, you can see that at baseline, there's really no difference going on. That same effect size is there during the restraint window from that secondhand smoke exposure, but that they don't actually return to that baseline recovery afterward. And so this is sort of important to consider because it suggests that even if we see some return to baseline and some recovery and some cardiovascular measures, that we're not seeing it in all of them. And so again, it sort of suggests that potentially stress in vulnerable populations may respond differently to previous exposures. And that's why I think it's really good to avoid them in the first place. And again, these are just going to show you that we did see stress exposure and the interaction as significant here. And again, it suggests that these cardiovascular consequences, they may not all be reversible, but some, in fact, do seem to be going the other way. So now I'm going to switch over and talk about public perceptions and how they influence risk. And this is a really cool study where they polled dual users, so people that use cigarettes and e-cigarettes. And they said, if you were given the choice, would you prefer to smoke, vape, or do you not have a preference in various scenarios? And you can see that people that are stressed, that just woke up, that consuming alcohol tend to prefer to smoke. And that the other sort of subset of scenarios, they overwhelmingly prefer to vape. And so this suggests that there's this belief, at least, that vaping may be safer and therefore people may feel more comfortable using it in more scenarios than they would smoking. And this isn't surprising. But when you look at specifically their responses to what they prefer to use around different tobacco users, you see something really interesting. When they ask you if you want to use a vape or a cigarette with a smoker, there's really a split group. They don't have any strong preference. But when you ask them what they want to use around a vapor, they overwhelmingly say they want to vape. Moreover, when you ask them what they prefer to use around a loved one, so that's going to be with their friends, at a family event, or with children, again, they overwhelmingly want to vape. And so again, these data suggest that they think these products are safer, so they feel more comfortable using them in more scenarios and potentially around, family and vulnerable populations like children. And so this sort of got me thinking, well, how do perceptions of risk impact the actual risk? And so our lab is pretty split between assessing health effects and air quality. And so some of my colleagues were interested in how vaping and smoking affected indoor air quality. And so they took some measurements from a subset of homes that I showed from that tobacco cohort earlier. Our participants were allowed to use these respective products for 45 minutes ad lib. And for the purposes of this slide, I'm going to focus on PM 2.5. So non-smoking or tobacco-free homes are going to be in purple, and they had virtually no detectable PM 2.5, particulate matter, it's just a size reference, in these households. And you can see on the right, the log transformed PM pollution is graphed. And then on the left side, you can see the mean of the PM for those households, as well as the maximum that was measured. So our smoking homes are going to be in pink, and on average, smokers spend about half of their allotted time smoking, about 22.5 minutes. And I just want to point out that secondhand smoke, which is essentially what we'll be measuring, is the combination of both mainstream expired and side stream smoke generated when the cigarette isn't being used, so that butt end of the sort of burning cigarette. And compared to smoke-free homes, there was significantly more PM in these smoking homes, which is, I just did some brief calculations, 22 times greater PM in smoking homes after they used these products for 20 minutes. So what about secondhand vape? Unlike smokers, vapors used their e-cigs throughout their entire home visit, which likely contributed to this large range of PM readings here. And compared to smoke-free homes, there was significantly more PM, but this wasn't significantly different from our smoking homes. I also want to mention that secondhand vape, if that's in fact what we want to call it, is demonstrably different from secondhand smoke because unlike cigarettes, there is no side stream emission. They don't generate an aerosol when they're not being used, and so everything that is emitted into the air and then measured has been inhaled and passed through the respiratory system of the vapor. And when you look at mean PM in vaping homes, it's roughly 66 times greater than that in non-smoking homes. And so again, these data suggest that maybe people feel more comfortable using them indoors, and so that could contribute to this, larger indoor air pollution we're seeing in these vaping homes, and that they may be more comfortable using them around family members. And so again, we're seeing significant amounts of PM in these homes during their use. And I just talked about PM 2.5 pollution and how it was associated with some tobacco products indoors. And when we think about PM specifically, size is a super critical consideration because it influences how far into the lungs these particles will travel. So here you can just see a schematic where you can see 60 microns is about the width of a human hair, and then you see some PM ranges to the right. And these are important because, like I said, they sort of tell you what they're going to do in the body. And so anything smaller than 2.5 microns is considered respirable. And what do I mean by respirable? And so here's just some examples of various respirable particles. You can see tobacco smoke falls into that range, viruses and bacteria, dust, pollen is a little bit larger than was typically respirable. And when I say respirable, here's an example. You see PM10, which is greater than that respirable range. It's going to go into the trachea. It's likely going to get coughed out. Nothing's really going to enter the lungs deeply into the alveolar sacs. But in these smaller ranges, PM 2.5 and PM 0.1, these can actually enter the lungs, go deep into the lungs, and get into these alveolar sacs. Then from there, they can actually enter the bloodstream and make their way into the brain. And there's an important subset of respirable particles, and these are the nanoparticles. These are 20 to 100 nanometers. And these are unique because they can actually access the brain directly through inhalation through your nose. They can actually bypass all your sinuses and go directly and deposit into your brain. And this is important because we know that e-cigarette emissions, like tobacco smoke, are sort of in that similar range. And so if you think about just from a size perspective alone, it's clear that not only are the lungs and potentially nose and sinuses, like I've been arguing, that these might be affected by these exposures, but potentially systemic effects via access from the bloodstream and neurological effects in the brain could be important outcomes from e-cigarette exposures. So I sort of want to end my pitch by talking about some latent cigarette effects and what this might mean for how we think about vaping. So here's a graph where on the left you can see the number of cigarettes consumed per capita, and you have years on the bottom, and you can see there's peak cigarette consumption is in the sort of 1940s, and that blue bar is going to be lung cancer death per 100,000 people, and you can see that peak lung cancer death is really latent by about 20 years. So between that peak use and those peak deaths, there's a huge latency window, suggesting that some of the effects we're looking at may not be immediate. Similarly, for cardiovascular, they looked at non-smokers and smokers and looked at the number of cardiovascular disease-free years and then the number of the years they spent having a cardiovascular disease. And this was in middle-aged adults. And they found that in non-smoking adults, and specifically men here, that they had about 29 years that were cardiovascular free. And compared to smoking men of a similar age, they had 5 fewer healthy years, and their life expectancy was also reduced by 5.5 years. A similar trend was true for females as well. And so I'm going to just wrap this up by making sort of reference to some basic toxicology aphorisms that I think are important to remember when we're trying to think how do we adapt our science to address this sort of evolving field. And the first is the precautionary principle. And this principle originated as a link to help us deal with uncertain scientific information. And it acknowledges that because science doesn't always advance quickly enough to establish absolute cause and effect, that one should use common sense when the science is uncertain or absent. And so to that I say, there are lots of studies out there, people are publishing all the time on vaping, and they may show an acute effect from vaping, or they may show that there's no effect from vaping. And these may all be very true and valid outcomes, but remember that single experiments only tell one sort of facet of a story. And so you need to think about this comprehensively. The second is the dose makes the poison, which is an adage from Paracelsus, who is the father of toxicology. And remember that in many cases, the dose, which is the degree of exposure or the concentration and the duration, and has a direct relationship with the magnitude of harm. And so we should be thinking about the dose of these tobacco products. And are these new products that don't require multiple puffs in a short succession the way that a cigarette does? You don't have to use an entire vape in one session. What is the dose of that? And moreover, Historical evidence and some work that we've done suggests that there's product-specific behaviors, and so that suggests that the selection of your endpoints is really critical. We want to make sure that we're not just using traditional endpoints because it's what we're used to seeing, and we risk missing an entire outcome because we're just not looking in the right places. The next adage is going to be all models are bad, some models are useful. This is one of my personal favorites from British statistician George E.P. Box. And he basically says that, models can be useful, and they're especially useful for toxicology and looking at mechanisms and studying LD50s for predicting risk. But as tobacco products get more complex and the populations become less clearly defined, we need to adjust our studies to try and mirror these populations better. And again, it's just a plea to model things that are really real world exposures rather than just these sort of super strict, controlled studies. We want to make sure we're actually representing what's going on in the real world. And finally, I encourage everyone to get creative with your research and to think outside of the box, but with caution. We tend to use techniques and approaches we've relied on for years to study something new. And I would argue that sometimes that simply won't get us the answers we need. And so when in doubt, look to the product users, or at least check in with what they're saying on Reddit. They're pretty candid and honest and give you a lot of information. It's the best boots on the ground information that I've been able to find. And so, we should be thinking about referencing them and taking what they say with more than just a grain of salt. And lastly, I think it's important to contextualize and improve tobacco messaging. This paper from Addictive Behaviors in 2016, I think, sums it up really nicely when they talk about communicating tobacco harm. And they say, well, compared to what? And so their take-home messages were that currently cigarettes are the default comparator, and that messaging influences harm perception. So if we say that vaping is less harmful than cigarettes, people hear that vaping is less harmful and they don't really interpret and think about the rest of that idea. And so we want to maybe say that vaping may cause harm independent of what happens with cigarettes. And that's why it's important to consider multiple comparators, like these non-smoking tobacco-free people I just mentioned, or other tobacco comparisons, such as dual users. And these are people that use both a cigarette and a vape sort of interchangeably. And just to sort of give you guys an idea of what's coming up in the pipeline, there's these new heat not burn devices that have been rolling out in selected retail markets. They're not, I don't believe, fully on the market in the US yet. And essentially, this is kind of like the love child of a cigarette and an e-cigarette. So essentially, they take tobacco, they compress it up, they dip it into a solvent, often the solvents that are found in e-cigarettes, and then they essentially heat up that solvent to extract those tobacco components, and you vape that. So you're basically vaping a cigarette. And we don't really know what the consequences of that are yet. And so just keep in mind that this is, again, a very fast moving and evolving field. And we should be thinking about how to, conduct our science and keep pace with that. And so with that, I just want to say science is absolutely a team sport. And I want to thank Terry Gordon and Michael Weitzman, my PIs at NYU, and all of our lab members who have contributed and helped me to conduct this work. Also, my UC Davis family, which is going to be Chow's lab, and June, my lab mate, Jay, who did our telemetry surgeries, and Kent, who did our animal exposures. And I would be remiss if I didn't thank my work from home teammates. And so Casanova is sort of the head of the household here. He's been with me since my first days at Davis. And over the past few years, I've added a few COVID critters to the mix. And while I'm not addicted to tobacco products, this may qualify me as an addict of baby animals. And it's certainly too soon to know if there are any adverse health effects associated with this affliction. But if there are, I will be sure to post about them on Reddit. And if you didn't get enough of this today, I will be at SOT talking about some cohort data and some secondhand effects in children next month. My lab mate June will be at EB, and she will be talking about more of the cardiovascular consequences of secondhand smoke and a high-fat diet interaction. So again, looking at that stress from a diet perspective. And also Jamie, who I believe is going to be fielding the questions from DSI, will be at both of these if you have questions about how to use their equipment to do some of these preclinical assessments. And so with that, thank you for your time.
Well, thank you, Emma, for such a fantastic presentation. That was really great. And with that, we'll jump right into the Q&A. And so first question here, Emma, can you go into a bit more detail about what information SDNN provides that SDANN and RMSSD do not? And so I think that we can go back to, looks like slide 29.
Sure, are you gonna jump there? There you go.
Yeah.
Yeah, so essentially they're all telling you about heart rate variability broadly, but as you can see on the bottom, I have sort of the vagal and sympathetic, which is isolated and intermediate. That's all encompassed in the overall, as well as other things like humoral factors and, hormones and age. All of those things are going to sort of affect that overall variability. And those, we know that variability tends to reduce over time and with age and with diseases. But it's really muddy when you look at that overall, which is why it's not the best indication of what's going on at like sort of a true autonomic isolated level, which is why we look at different time frames to try and understand which components might be impacted. And I will say that while it is a clinically validated risk factor, that we don't, I don't think, have an appreciation for how much heart rate variability has to diminish in order for it to become pathologically relevant. We just know that in people, when they monitor them over time, that when we see a reduction in that same person, we know that that tends to be associated with worsened outcomes. So it's not understood as far as like exactly the threshold that's needed to be changed in order to see a difference, but it is helpful in terms of tracking one's own sort of health from a cardiovascular regulatory or regulation perspective.
Awesome. Great answer. Um, Interesting question here from Ginny, who's asked for air quality data. For example, in New York City, where lots of the population lives in multi-unit dwellings, um, there could be third-hand smoke residue. So, have you assessed, neighbors' smoking habits, or do you know of any data that might look at this?
So that's a great question. We're actually working on some studies now trying to look at that specifically, like trying to assess exposures in hallways, for example. Again, it's really hard to pinpoint the exact source of that because, we don't know the relative contribution from one unit to another. In addition, a lot of New York City has banned smoking indoors. It doesn't mean people don't do it, obviously. But it is sort of discouraged, and so people tend to do them near windows. That was our experience in our homes, at least, is that people tended to use these products closer to the windows. And so it's a great question, and it should be studied more, but currently we don't have the data.
Right, makes sense. Um, so, another question here. Did you use a nasal swab to get the cytokine concentration? So. I think that would be talking about this slide here, the study.
Yeah, so we use Lucozorb strips, and actually Alona Jasper's lab at UNC are the group that really perfected this, and we work with them to generate and get these materials. But essentially, they've optimized this. It's a way to get nasal information in the field, and it actually is a very stable way to get it. I think they're trying to optimize it for use in like a field a field scenario. So it's just a Lucozorb strip that you can buy. We cut it up and then we basically clamp the nose for 2 minutes to make sure that both sides of the nose are touching the strip, and then we just extract the proteins from that and run those.
All right, great. Um, all right, try to squeeze just a few last questions in here. Rosendo has asked the fact that vaping increases nasal inflammation compared to cigarettes. Has anyone found an association between sinus or nasal polyposis and vaping?
So great question. I That's kind of my where I'd like to go with this next, is trying to understand if there are actually pathological and sort of upper respiratory outcomes associated with these inflammation. We see a lot of the same cytokines elevated in our vapors that are elevated in patients with chronic rhinosinusitis, which is just defined by sustained upper respiratory and nasal inflammation. But again, the etiology of CRS isn't really known, and we don't particularly know if this is a way to make someone have CRS or if it really sort of exacerbates that or not. But great question. And again, these data are coming out in April in the ATS Red Journal. And so, hopefully this will spur some people to maybe look more closely at the upper respiratory effects in these users.
Yeah, definitely. I mean, even just advancing in the slides just a bit here. But yeah, looking at these, I mean, it's clear that there's some things that are going on in vaping that just you don't see in smoking, and so it's going to be really interesting to see where the research goes because, um, yeah, like nasal polyposis, these are things that we don't see in smoking, and so yeah, research that really has to be done.
And I will just add that we also looked, I didn't present any of the hookah data, but we did look at hookah users as well in the similar context. And hookah smokers are remarkably similar to vapors in terms of the nasal inflammation. So again, a lot of nasal inflammation in hookah smokers, not much going on in cigarettes, which was surprising to me because I sort of expected that tobacco products would bias together. And again, we found similar increases in nasal exhalation in those hookah smokers as well. And so again, it suggests that maybe how they're using is affecting different tissues and therefore leading to different outcomes. And so I think that there's quite a bit that we can be doing in the future about this.
Interesting. Well, I think in the interest of time, we'll just have one last question here. One from Guido, who's asked if you're aware of any correlation between vaping and allergy.
Another great question. Unfortunately, when we were doing these home visits, this wasn't something we thought was going to be interesting, and so we just sort of like happened to look at nasal inflammation compared to saliva, and we saw it more in the nose than in saliva, which was not what we expected initially. So certainly we are doing more nasal swabs now, and we are asking much more about their allergy status, and we're also asking if they're on allergy medication or sort of antihistamines and things like that. And these are longitudinal studies that we're now conducting. So we're trying to see if these change over time. So hopefully we can actually correlate that back to changes in allergies and seasonality and things like that.
Fantastic. Well, Emma, thanks so much for sharing your insights today. It's been a real pleasure having you with us.
Yeah, thanks, Liam, so much.
Yeah, absolutely. And a big thanks also to the audience here for participating. And last but not least, we'd like to thank the sponsor, DSI and Harvard Bioscience. So in closing, we hope you enjoyed this Inside Scientific webinar, and we'll see you again next time. Have a great day, everyone.